Hello everyone, welcome to yet another problem from Leetcode. It says number of island. The problem goes like given an element to an 2D binary grid, a grid which represents a map of ones which is land, zeros which is water. Return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are surrounded by water. So in example 1 you can see over here there is a one island which is connected by this one from the left part and right part, and in the example 2 we can see there are two islands, specifically these four ones and these three ones. Sorry, there are two islands, this four one, the two ones individually here and one independent. Remember the diagonals are not connected, so we cannot say that these are only one island. So we need to have adjacent ones, then only we can consider the islands are connected. So in this case, we need to go ahead and walk through the islands until we find any water, and then we need to count it, the number of islands that we have encountered so far. So let's do that then. So what we can do over here is we check if the cell is island. Okay, island. Hmm. If yes, go and check how large it is, or go and if we found that it is an island, so we go iterate it. Then post iteration, we go to the next cell, checking for that island. And meanwhile, we keep track of islands visited. Make sure, makes sense, right? So let's go via a simple count variable, or we can directly return a count from the iteration. Let's use a count variable. Cnt is equal to 0, and for int I is equal to 0, I is less than grid.length I plus plus. And within each row, we are iterating through columns. So for int j is equal to 0, j is less than grid of I dot length j plus plus. And we check whether it is island or not. So if it is island, we go ahead, we increment the count. So count plus is equal to is island, then we check, then we get to know that yes, it is an island, and we increment the count by 1, else we do nothing, we increment 0. And also to make sure that it is an island, we need to pass grid and the location what we are speaking about. Here we are speaking about I and j position. Ultimately, we return count. But wait a second, what is island? So it is nothing but a boolean method which says is it an island or not. So we take is island, and we have int grid, int I, int j for row and column mapping. And obviously we are checking of row and columns within grid. We need to check that grid is not null, and grid is also, obviously we are checking it here as well, so we need to check it here. If grid is equal to null, then we go ahead and throw new illegal argument exception. Yeah, if it was null then. And in this case, we are already checking null. Then go ahead and check for INJs. If I is less than 0 or j is less than 0 for that matter, or let's say I is greater than or equal to grid.length, or j is greater than or equal to grid of I dot length. We are checking ahead with this. Let's make it more readable by doing this. If any of this happens, then we know that state is invalid. In such case, we can say that it is not an island. So return false. But if we see that it is a valid index, then we can say that yeah, there might be a possibility of having an island. Why I'm saying might be? Because it is an island if and only if it is not an island if and only so it is an island if and only if grid of I and j is equal to 1. But if I and j is 0, then it is C. It is C. And in this case, we return false. So within our earlier logic, we have said that once we found an island, we need to keep iterating and checking for the next cells. So we go ahead, check upon the next cells, and in the DFS manner, obviously, and we check is island for the current grid, obviously going adjacent ways only. IJ is island. We go grid I minus 1j is island grid I and j plus 1, and ultimately we go to j minus 1 and we return true. Why true? Because yeah, at least the cell which we have found was not 0, which means it is 1. Let's say over here we found an island, and we found an island, we went through iterating, and then we say yeah, we found the island previously, and then we are returning now that we found an island, so that is true. This island would return true, which will control will come over here. The true will add up one count from the count to the count, and ultimately will fill up the count and return the count as per this logic. So let's try to run this. It seems the semicolon is missing over here. Huh, let's try to run this. Okay, I see it is a character array and not integer array. So let's use a character, and if this is 0 in this manner. One major thing, we found an island, so we need to mark it as yeah, we have visited it and do not visit it again. We do grid of I j is equal to 0. Let's try to run this. Oh, it is not that 0. It is character 0, my bad. So as you can see that we have accepted the solution. Let's check it from the rest of the test cases as well. And yeah, the problem is solved. And yeah, it works well with other test cases as well. But we have not baked most of the Java submissions. Why so? You see, by default, the DFS traversal is time consuming. As you prepare a stack, you iterate through it, and you went ahead solving the stack which is on the top, and then you go ahead back. So it is something a tedious process to do. We can remove this, and we can overcome this by having a traversal mechanism known as BFS. So how do we do that?
Our best days pass us by, and most long for a place that they never find.